Welcome to example problem number 4. These ones actually are quite a bit simpler than the first 3 problems. So if you finish the first 3, well done. That's the hard stuff. Now it's super simple. So we'll run through this real fast. So a large donut-shaped, let me read through this problem first. So a large donut-shaped section of a spacecraft is being designed for a long-term spaceflight. The outer wall of the rotating section will become the floor for the astronauts, and the centripetal acceleration produced by the floor will simulate gravity. If this section of the spacecraft has a radius of 600 meters, what velocity, so there's my condition, will produce an acceleration of 9.8. Okay, so let's draw a picture of what we got going on here. So, got a circle, specifically a donut, but so that means there's a little circle on the inside here. And the astronauts are going to basically be on the outside. Boop, 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 like that. So they can survive, okay? We know that the radius of the spacecraft, so I'm going to put this here to figure out the radiation. This is the radius, and it is equal to 600.0 meters, okay? And that it needs to produce an acceleration, which means that it needs to move with a velocity this way, which we don't know. That's the question mark. So that there's an acceleration, centripetal acceleration, that is equal to 9.81 meters per second squared. Okay. Now, for any of these circular rotating problems, there's one main equation to be used, and it is this one. A of C is equal to V squared divided by R. Pretty simple, straightforward. So, notice here in this one, so for our plan, right, there's only really one step we're going to need to do, which is solve for velocity. Solve for velocity. So, let's do it. Okay, so let's do it. Let's solve for V. So V is equal to question mark. Okay, so we're going to use that one equation again. So AC is equal to V squared divided by R. I'm going to rearrange it. So I'm going to times both sides by R. And then this side by R. That cancels that out. So then I've got R times AC is equal to V squared. And then I'm going to have to square root both sides so I can eliminate that square there. So then V is equal to the square root of R times AC. All right, and now we're just going to plug our equation in. So square root sign, radius of this was 600.0 meters, and then I'm going to times that by the acceleration I need. So I'm going to make that 9.81 meters per second squared. Okay, so when I do that math, so I'll do 600 times 9.81 gets me that. So then I end up with an equal sign square root of 5,886. And then this is square rooting, yep. And so then I'm going to square root that number. So second square root, 5,886 comes out to 76. So 76.7 meters per second. That is the velocity that I'm going to need to go at. And that's the answer. So 76.7. I'm going to write that in here. 76.7. And that is how you solve that problem.